Hello, I'm Andrew Fraknoi. I'm the friendly neighborhood astronomer for the San Francisco Public Library. And I'm delighted to welcome all of you to this special program on the April 8th eclipse of the sun, which is coming up. I just want to say before I start that I'm a big fan of the San Francisco Public Library. In my retirement, one of the things I'm doing is trying to write science fiction stories based on good astronomy. And that creative atmosphere that you need to write a story is really wonderfully there at the library. I've written all the stories that I've written so far at the San Francisco Public Library, where I go with my laptop and my earphones, and it's just a wonderful environment for a creative person. So I'm always delighted to be working with the San Francisco Public Library. Let me now begin to share my screen. Here we go. Lori, nod if you can see my slides. Yes, she's nodding. Excellent. So we are in for a treat in the sky, and not just us, but everybody in North America is going to be able to see some sort of eclipse of the sun, weather permitting, on April 8th, 2024. So let's talk a little bit about what's coming. Uh, some of you may remember that we had another eclipse on October 14th of last year, and it's quite rare that the same country gets to see two eclipses of the sun so quickly in a row. But if you missed the one in October, you still have the one in April that you can enjoy. So what happens during an eclipse of the sun? It's a remarkable coincidence that as seen from Earth, the moon and the sun happen to be the same size in the sky. And because of that coincidence, the moon, which is much closer, can cover up the sun, which is much bigger and much further away, and we can get an eclipse of the sun. Sometimes only part of the moon covers the sun. Sometimes all of the moon covers the sun. But we have this wonderful coincidence that they happen to be the same size. We actually checked to see if this coincidence was true for any other planet and moon in our solar system. And the answer turns out to be no. On no other world is there an exact coincidence between the two. If you don't believe me, here's from the surface of Mars, one of the moons of Mars trying to eclipse the sun. And look, it's doing a pathetic job of it. The sun is much bigger than the moon in this picture. And so we are seeing an eclipse which is very partial and very inadequate compared to the one that I'm going to talk about today. So congratulate yourself. You were born on the right planet for eclipses of the sun. So here's what's visible when the coverage is total. When the moon gets fully in front of the sun, suddenly you can see the outer atmosphere of the sun. You can see the great arches of hot gas, which are being emitted by the sun and falling back. You can see some of the prominences, the great globs of hot material that get loose from the sun. All of this is much too faint to be visible when the sun is shining, but it's easily seen when the total eclipse happens. And it's because of this wonderful effect that the moon covers the sun, the sky actually goes dark, and you can see the outer layers of the sun, that eclipse aficionados, eclipse fans, travel thousands of miles sometimes to see a total eclipse of the sun. Let me tell you more about what's happening here, but let's just review what the geometry is. The sun is further away, the moon is closer. When the two line up, the moon casts a dark shadow spot on the Earth. And if you're in that shadow spot, the moon blocks the sun. If you're not in that shadow spot, but close to it, then you get a partial eclipse, which is what we'll see in the San Francisco Bay Area and in many other parts of North America. But because the Earth turns and the moon orbits, the shadow spot doesn't sit still. In the course of this great cosmic cover-up, the spot moves along the surface of the Earth at pretty great speed. And so it will cover some territory. And let's take a look at what's going to happen. And first, I want to just say that depending on where you are relative to that dark shadow spot, you can either see the total eclipse, where the sun is directly behind the moon and no longer visible. You can see what we saw in October, where the moon is a little bit further away in its orbit. Its orbit is not exactly a circle. And when the moon is too far away to completely cover the sun, you get a ring of fire visible. Another word for ring is annulus. So we call this an annular eclipse. That's what we had in October. The moon was so far away, it didn't have what it took geometrically to cover the sun completely. And then if you're not in the shadow spot but outside it, then you get to see a partial eclipse of the sun. So here's what they look like when they look the best. In a total eclipse, as I say, you can see the glowing outer layers of the sun, which we don't normally see. In the annular eclipse, you see this dramatic ring of fire. And in the partial eclipse, you see a big bite taken out of the sun, which is not something you see normally. It's almost as if it was a crescent sun. We're used to a crescent moon, but nobody sees a crescent sun. But during an eclipse, partial eclipse, that's what you get to see, and some beautiful photographs are possible. All right, here is the shadow spot. In case you don't believe me, we photographed the shadow spot in a previous eclipse from the International Space Station, and you can see the beautiful circular shadow. If you're inside this zone, you see the eclipse as total. And just before the eclipse happens, you can see the last little bit of light shining through one of the valleys of the moon. And you get this lovely effect, which some people call the diamond ring effect. This is the last thing you see before the eclipse goes total, or the first things you see after the moon starts to move off the sun and the eclipse is no longer total. So many eclipse fans are big fans also of this diamond ring effect. So in our particular case, in just a couple of weeks, on April 8th, Monday, April 8th, so it's a work day, this is going to be visible in some ways in Mexico, the United States, and Canada, and we're calling it the Great North American Total Solar Eclipse. Here's the sequence of events. If you are in the dark spot, the moon starts to move across the sun. More and more of the sun darkens. You get the diamond ring effect. Then you get the total eclipse. In our case, in April, we will see about a 4-minute eclipse at the best location and 3 minutes or less if you're not in the best locations. And then after those few minutes of total eclipse, the moon shadow moves off the sun, and you then begin to get the full sun coming out again. So where will the eclipse this April be total? The purple lines show you the extent of the dark shadow. If you're inside these purple lines, you will see the total eclipse. If you're outside the purple lines, you will see a partial eclipse. If you're at the red line in the exact center, that's when you'll see the longest total eclipse of the sun. So again, people who are real eclipse fans are not just getting into the zone bounded by the purple lines, they're making sure they're where the red line is, in the center, so they can enjoy more seconds of eclipse than people further off to the left or the right of the red line. So what's included in the eclipse path? Many parts of Texas, populated parts of Texas, including Austin, Dallas, and Fort Worth, Arkansas, Indiana, with Indianapolis being close to the center line, Ohio, upstate New York. By the way, Niagara Falls is very close to the center line, so you can already imagine the kinds of weddings that are being planned in Niagara Falls. And then moving off into New England, into Vermont and Maine, and then off into eastern Canada, the islands off the eastern coast of Canada, and out into the Atlantic Ocean. So that's where the eclipse will be total. Everywhere else, it will be partial. Now, we were able to calculate, we have a map maker and geographer who's working for us. He was able to calculate that 32 million people in the United States live inside the path of this eclipse. And it's possible that millions of others will go into that zone, either having planned it 2 years in advance or just waking up that morning and deciding to what the heck, miss work and do it. The scary thing is that 75 million more people live within 100 miles. So you would drive 100 miles to see a singing star that you particularly like, or to hear a speaker that you've always admired. And so it's possible that some of these 75 million people will wake up to the eclipse happening a couple of days before when the media wake up, and they'll just decide to drive in. That'll be in addition to all the people who planned long ago to fly into that zone. So that's going to put a real pressure on services inside the zone, particularly small towns. We have been working for 2 years with the Emergency Management Agency of the federal government and of the states to try to prepare the communities in that zone to be ready for a huge influx, a much larger than usual influx of tourists. Here are some of the places where the eclipse will be total. On here should have been Mazatlan, Mexico, and Torreon, Mexico are places where you'll see the eclipse for 4 minutes. San Antonio, Dallas, places near Little Rock, Arkansas, Indianapolis, Cleveland, Niagara Falls, Buffalo, and Rochester, New York, etc. And let's take a look at one of these places. I'm going to pick Carbondale, Illinois. Now you might say, I've never heard of Carbondale, Illinois. Why did you put that on the list with much more famous cities? It's because Carbondale, Illinois was also a place where the 2017 eclipse that we had, the last time we had total eclipse in the United States, it was total in Carbondale as well. It's one of the few towns where we will have a total eclipse in 2024, and we had one in 2017. And Carbondale can't get over this. They are just so full of themselves, it's impossible to talk to them. And so they're declaring themselves the eclipse capital of the country. But let's just pick that. The partial eclipse begins at 1240 or so, and it's not over until 318. So you can see that's quite a few hours. That's more than 2 hours to view the eclipse in all its various phases. Then at about 2 p.m., the eclipse will begin to be total, and the total will end in just 4 minutes at 2:03 p.m., and then there'll be a long time when it's partial again. So although the total phase is quick, the partial phase is slow. So people have a long time to find a good location, make sure all the kids are doing the right thing, get the bottles of water ready, and then be ready for that 4 minutes of total eclipse. The problem will be the weather. Generally speaking, the further north you are, the more likely it will be cloudy. And so that's a big problem for people in New England. Here's a nerdy graph that a weather person who loves eclipses did for us. It shows you the likelihood of clouds in fractions. So 1 is 100% likelihood, 0 is 0% likelihood. So this is the likelihood of cloud cover going along the eclipse path. And you can see Mazatlan is really in a good shape, because in Mazatlan, it's only about 25% chance of cloud cover ruining the eclipse. As you get to Texas, we're getting up to 50% chance of cloud cover. So you got to make sure your location is going to have good weather. And generally, weather is very hard to predict until we're quite close to the eclipse itself. Then as we go further into, for example, Indianapolis, we're now almost at 70% chance of cloud cover. If you go to Quebec in Canada, your chances are 85% that it'll be covered. So I wouldn't pick that as the place to go. Notice Rochester, New York is down again from Indiana. Rochester, New York is only 60%. So many people are picking these towns that are sort of Cleveland, Rochester, etc., are places where there's a slightly better chance of seeing the sky. But this is going to be a big issue, which is why so many people are going to Texas, even if they disagree with the politics there. The best website for keeping track of weather in an eclipse zone is run by Jay Anderson, a retired meteorologist who's an eclipse weather expert. And his website is eclipsophile.com. Phile is a root that means lover of. So this means eclipselover.com, eclipsophile.com. That's where I would go if you're unsure about the weather prospects in a place that you're picking. And here again is a nice map provided just to show you that there is a lot of Mexico that I didn't show you before, where the eclipse will be total and the cloud cover is less, but not all of these places in Mexico are so welcoming to tourists. So you have to also be careful about public safety if you're thinking about going to Mexico because the weather is so good. Here's a detailed map of Texas, just to show you. Here's San Antonio, Austin, and Fort Worth. The purple lines that I showed you before are now yellow lines. This is the edge of the total eclipse zone, and the middle is right in the middle here. So notice, for example, if you like Austin as a college town and you decided you wanted to go to Austin, in Austin, you only get about 2 minutes of eclipse because you're very near the edge of the eclipse zone. So many people who may have stayed in Austin on Sunday night will then decide on Monday morning they're going to drive somewhere. They're going to take one of these highways out of Austin, and they're going to try to go as close to the center line as possible. But there's very little civilization there. So whatever small towns and rural areas are in the middle also need to be prepared for people needing water and bathrooms and things like that. That's the challenge of the eclipse. Similarly with Dallas, if you were to go to Dallas or Fort Worth, it's kind of on the edge, and many people are going to try to take one of these highways out of town to try to get more toward the middle and see a longer eclipse. And that's going to tax the highway structure and the services in the middle zone. Just a friendly warning if you or someone you know is intending to travel there. But it's not bad in Dallas. In Dallas, you get 3 minutes, 50 seconds, which is not bad. If the weather's good, I'd stay more with civilization and not worry about the extra 20 seconds. Now, where did I get all these maps? Many map resources are being made available at the Great American Eclipse website. Michael Zeiler is a retired map maker and geographer, and he specializes in wonderful eclipse maps. So if you want to see a good map for any part of the United States, that's the website I would go to, Great American Eclipse, all one word, .com. That's where I get my maps, and that's where you can appear to be an expert as well. So what will the eclipse be like in major US cities? I'm particularly interested in this column, which shows you how much of the sun's diameter will be covered by the moon. And you can see in New York City, maximum coverage is 91%. That's a big bite taken out of the sun. Not bad. So if you're in New York and you can't make a trip to New England, it's still quite nice to see 91% of the sun's diameter covered at 3:26 p.m. in New York City. And I'm going to show you the website to go to get these numbers. You don't have to write any of these down. There's one easy website that gives you all the numbers you need. Now you can see in Houston, it's 94%, Philadelphia, 90%. We said Dallas is 100%. Here in San Francisco, we'll talk about it. We have about a 45% bite, still a good sized bite. And the cover up in Washington, D.C. is 89%, which is pretty typical of the cover up in Washington, D.C. No, I didn't say that. No political statements in a San Francisco Public Library talk. I'm sorry. Um, and you could calculate these numbers and these times for any city by using a website. But let's first talk about the Bay Area. So as I said, here 45% of the sun's diameter will be covered at maximum, which on Monday, April 8th, will be at 11:13 a.m. So whether you're in school or at work or at home, I hope you'll be able to get the time around 11 to go outside and use one of the safe methods that we'll be discussing to get a good look at the eclipse sun. The next eclipse visible from San Francisco, the next total eclipse that crosses the United States will be in 2045. So if you don't get to see this one, it'll be a while before there's another one crossing the United States. So in San Francisco, the eclipse begins at about 10:14 and ends at 12:16. So you can see that there are 2 hours for the partial eclipse, with the maximum roughly in the middle. So you don't have to rush. If you don't get there exactly at 10:14, you won't miss anything because the moon will just start to cover up the sun. And at first, that's almost invisible. So again, if I were picking the time I want off from work or school, I'd go from 11 to 11:30. That's when the big bite will be taken up. And, that's not bad. At 11, if you think about it in April, the sun's pretty high in the sky. So if you live where there are buildings and trees, chances are the sun will have cleared at least lower buildings and trees. On the other hand, if you're in the middle of Manhattan or downtown San Francisco, you might want to make sure that you get into a viewing point where you can actually see the sun at 11, because the sun could be behind a tall building, or in San Francisco, behind a tall hill that blocks your view. So I recommend that people go out the day before at 11 on Sunday and check out where the sun is. If you can see the sun from your intended viewing location at 11 on Sunday, April 7th, then you'll be able to see it from that location on Monday, April 8th, and you'll be able to see the eclipse. So those are our numbers in the Bay Area. So what if you didn't write down all the numbers on that chart, or what if you have relatives or friends who need to know what the eclipse is like for them? Here's the one website I hope everyone writes down. And Lori, maybe you could put this in the chat if you wouldn't mind. The website is time and date, all one word, timeanddate.com/eclipse. Time and Date is a wonderful service website that tells you all about astronomical happenings in our area, in any area, I should say, and tells you about the time and other things that we calculate. But it also has an eclipse page. And if you go to timeanddate.com/eclipse, you can pick any upcoming eclipse, like the one on April 8th, go to its page, and then there's a little field where you can put in your community. You can put in San Francisco, you can put in Akron, Ohio, you can put in whatever little community anywhere you want, and it will then give you in everyday language and local time what the eclipse will be like for that location. So that's where I got all my numbers from. And if you have friends or relatives who want to know what the eclipse will be like for them on April 8th, that's the place to send them. timeanddate.com/eclipse. All right. Now, we've put many of the charts that I'm showing you and some of the hints that I'm going to give you into a brochure for teachers, but it's really for anyone. It's not technical. So if you're interested in getting a brochure with some of what I'm talking about today, it's a virtual brochure that you can send to any of your friends or relatives. And it's just got the short address bit.ly/eclipses for teachers. We did this for school teachers, but as I say, anybody can use that booklet. And it's that same grant that got all those eclipse classes that Lori so kindly mentioned that also paid for us to work with teachers. And I'll say more about that in a minute. So who will see some kind of eclipse in 2024? We did the calculation, and it turns out to be, weather permitting, 500 million people. When we heard that number, we really freaked out because that's a lot of people to educate before the eclipse happens. And there's no way, with no matter what foundation we go to, that we're going to get 500 million safe viewing glasses. So what the heck are we going to do? The problem is whenever any part of the sun's surface is showing, it's not safe to look at the sun with unprotected eyes. It's also not safe to look at the sun with dark glasses, with sunglasses. Sunglasses will help with the glare on the street, but they are by no means safe enough to stare directly at the sun. So what were we going to do? Well, there are these paper and plastic glasses that is made with a substance, a plastic substance you see here in the middle of the glasses that the baby's wearing. This plastic substance can cut down enough of the view, enough of the intensity of the sun, so that the sun is safe to look at through them. And that's what Lori was saying. The San Francisco Public Library will be offering these glasses to its patrons, which is wonderful, through this program, but they're not going to do it until 2 weeks before the eclipse begins. And everybody should have access to these glasses or another safe viewing method, and I'll talk about the other ones in a minute. When we announced this, people paid a lot of attention to the need for safety. Not quite everybody paid attention, but most people paid attention to the safety, and people didn't look directly at the sun with unprotected eyes. What we need is lots of safe viewing glasses and lots of help for the public. And we said, how could the astronomers of the country ever do this? There are only 6,000 astronomers in the entire United States. There's no way we can do this alone, but we realize that many communities already have a built-in information distribution center, which is the local public library. God bless them. And so we said the best people we could work with, we astronomers, would be the public libraries to get glasses and information out. And that's when, as Lori kindly mentioned, the Gordon and Betty Moore Foundation very kindly stepped in. We had worked with them in the previous eclipse. And to their credit, they have funded the distribution with a little help from the National Science Foundation, but they funded the distribution of 6 million eclipse glasses, and they're being distributed free to the public through 13,000 public libraries, including the San Francisco Public Library. And because the eclipse is slow, you don't need a pair of glasses for everybody in the family. One pair of glasses is fine. You can look at the sun with the glasses when it's partially eclipsed and then give it to someone else, look away, let that person look and let the next person look, and it'll get back to you in a few minutes and the eclipse will still be a big bite taken out of the sun. And if you happen to be in the eclipse zone, once the eclipse is total, then it's perfectly safe to look with your eyes. During those 4 minutes, when the moon does us the courtesy of covering the bright shine of the sun, the eclipse is not only perfectly safe to look at, but beautiful. It's required that you look. If you have binoculars and you're going to be in the total eclipse zone, please take your binoculars. They will show you an even more spectacular view. It's just outside the zone when the sun is only partially eclipsed, like it will be here in San Francisco. It's that partial eclipse time that you need to have glasses on. And as I say, that's slow, so you can share glasses. So if 3 people share each pair of glasses, that's 18 million that we've now got covered. That's still a lot less than the 500 million who can potentially see the eclipse. Libraries are getting involved. We also wrote a booklet for librarians and library patrons, which is also available free of charge. It's virtual on the web. It gives you many of the same things that I'm talking about in this lecture, including safe viewing methods. And you can find that at bit.ly/eclipses for libraries. So you can either go to the booklet Eclipses for Teachers, or you can go to the booklet Eclipses for Libraries and share that with friends who are not here at the lecture or relatives, and they will help get the information out to their own communities. In addition, we have funding to train 275, now it's actually over 300 science teachers to be our secret agents for the eclipse in their communities. And these 300 agents that we've trained, and NASA's also training teachers, and the Astronomical Society of the Pacific, which is a San Francisco-based organization, is also training secret agents to go out. So we have perhaps 2,000 people who have been trained around the country to help libraries and to help communities with eclipse lectures and eclipse viewing. Just like I'm doing this for the San Francisco Library, and I did it for the Oakland Library, there are people doing these kinds of talks and making viewing sessions available for libraries and community fairs around the country. Here's the book for teachers that I mentioned. It's not as fancy as the one for libraries, but it has some of the same information, and that's at bit.ly eclipses for teachers. In fact, we are working with the National Science Teaching Association. If you know a science teacher, please pass this on to them. The National Science Teaching Association has a dedicated website at their own website, nsta.org/eclipse. And there are many, many teaching resources there for science teachers who want to do a lesson around this rather spectacular happening in the sky. It's as if nature were doing a lab activity right in the sky on April 8th. As Lori kindly mentioned, my writing partner Dennis Schatz and I have written a children's book for this nonprofit publisher, NSTA Kids. And it's available. It's called When the Sun Goes Dark. It's available on Amazon and from the publisher itself and many other places. It's an illustrated book that explains eclipses to kids. So if you have kids or grandkids who would like to learn more about what's really going on April 8th, if I may be slightly immodest, I recommend this book as a nice present for them. Here's one of the interior pages. So here, for example, is an activity that kids can do with tennis balls and a lamp to show the shadow play during eclipses. And it's a lot of fun for kids to be able to act out what happens during the eclipse. And then they'll go on April 8th out under the sky with a new kind of understanding. So it's some grandparents showing kids how to understand eclipses. Now here, this is something I wanted to mention, which I don't get any money from this. I'm only saying this as a public service. A friend of mine, an astronomer by the name of Douglas Duncan, has invented something called Solar Snap. And it's a smartphone eclipse filter and app. It snaps in front of the camera of your smartphone. And it's an app that takes over your cell phone camera functions, and it allows you to take safe and pretty good pictures of the eclipse with your cell phone. Nowadays, many people only think of cell phones when they think of photography. It's very dangerous to look at the sun when it's actually showing some of its bright surface. Very dangerous to look at the sun through a cell phone, just like looking at the sun with just your eyes. So don't do that. But if you can get this little app and put it on your phone and put the filter on your phone, that allows you to take a picture of the eclipse with your cell phone safely. It's called Solar Snap. You can just Google it on the web. One place you can get it is American Paper Optics, which is the main manufacturer of those safe eclipse glasses that I talked about. If you go to American Paper Optics Solar Snap, you can get information about how to get it, but get it soon, because this is the time when these glasses and these apps are really selling. and we expect that many things will be sold out by April 8th. And using a camera, this is not a cell phone camera, this was a professional photographer, you could take some pretty dramatic pictures even of the partial phase of the eclipse. Here's a partial eclipse of the sun with clouds above the skyline in New York City. Really a nice image. So the biggest thing I want to talk about in terms of getting ready for the eclipse is to be thinking ahead. In Texas and in Arkansas and in all those places where the eclipse will be total, it's very likely that we'll have gridlock just before and just after the eclipse. So if you're going to a big eclipse observing party, make sure you have water and food for the kids, you have sunblock and sunshades and hats for everybody. And if you're there in the sun, be prepared to stay for a while. Traffic is going to be quite strong after the eclipse is over and probably just before the eclipse begins. The biggest issue for many of the small towns is that when there's an eclipse, people still need to go. And where are they going to go during an eclipse? We need porta potties in all those places where there aren't a lot of municipal bathrooms. And so we've been encouraging for years now some of the communities under the total eclipse shadow to make sure they order enough porta potties for the crowds that they expect. I just heard last week that there's a town in Texas with a population of 20,000 that is expecting 200,000 tourists. So that's 10 times their population. They're going to need porta potties. This is not the first time that we've seen an eclipse. Here's a headline from 1918. There was also an eclipse crossing the United States, going southeast rather than northeast. But as I say, there's been some historic memory of these eclipses, but it's very rare that they happen in the exact same communities. And so, generally speaking, we start from scratch with each eclipse. The important thing is to plan ahead wherever you're going to be. Don't leave it till the morning of April 8th to decide what you're going to do. Many libraries are going to have eclipse viewing parties, just like they did in 2017. Check with your library to see if something is happening. Many schools are going to have ways of helping the students to observe the eclipse as well. Now, what are some other safe ways if you can't get these special glasses? One thing I like, which is relatively easy, is to use a hand mirror. If you have a hand mirror, you can tape some cardboard to the hand mirror and cut out a small hole about the size of a dime or even a little smaller. And it doesn't have to be a perfect hole. Look at the messy hole I cut in this picture. The shape of it doesn't matter. It's only that you're cutting down the amount of light. Take this hand mirror with the small hole, make sure the cardboard is on tight, and then use that mirror to reflect an image of the sun onto a wall. And then you will be able to see the eclipsed sun quite safely. Again, catch the sun in the mirror, then reflect an image onto a wall or screen. You can also put the mirror on a stand if you want and get a screen to project an image. And this is all something you should practice the weekend before. Don't do it only for the first time on April 8th. Make sure you know what you're doing. It takes a little skill to project a good image and angle it just right. But this image on the wall will be perfectly safe to look at, even though looking directly at the sun will be unsafe. So that's one way to do it. Another way we've discovered recently is a disco ball. If you have a disco ball on the street, the disco ball surfaces will reflect images of the eclipsed sun on a wall nearby. Now, you might say, Professor Fraknoi, where the heck am I going to get a disco ball before April? But I'm here to tell you Amazon sells disco balls at discount prices. So if you really want to use a disco ball, it's still not too late to order one from Amazon. Although a number of astronomers have been giving lectures like this, so maybe they're going to be out of disco balls soon. The classical way to project an image of the sun is to take a piece of cardboard, make a little pinhole in the middle, and then hold the cardboard over your shoulder and project an image, a pinhole image of the sun onto a sidewalk. But that image is awfully small and undramatic. So I have a much better way of using pinhole projection. I'd like to recommend that you use a colander. A what, you say? A colander. We all use a colander to wash salad or pasta off, and it's made up of a whole bunch of holes. If you stand on the street with your back to the sun and angle the colander on your shoulder in such a way that the shadow of the colander falls on the sidewalk or on the street, or even better, on a white poster that you brought and put on the sidewalk, that image, that shadow, the pinhole projection of those holes will show you a whole bunch of eclipsed suns all around the shadow of the colander. This is actually a photograph taken during the last eclipse. You're holding the colander over your shoulder. You're not looking at the sun. Your back is to the sun. But the shadow of the colander with all those pinholes will be a dramatic way of showing the progress of the moon across the sun. And if you're standing in the middle of the sidewalk with a colander on your shoulder for a long time, your neighbors will come out and wonder if you're okay. And then you can say, yeah, I'm okay. I'm doing a major scientific experiment here, projecting the shadow. And your whole street can gather around you, and you can be the hero of your neighborhood. So that's my favorite way of showing the eclipses, using a colander with your back to the sun. If you know what you're doing, you can cover up one end of a binoculars, one of the two viewing surfaces of the binoculars, project an image through the binoculars. But again, you need a tripod. You need to practice this. This is probably only for people who have a good sense of how to do this. But if you are familiar or comfortable with optical things, you can do that as well. If you want to know where to get safe viewing information, one more website that I want to recommend to you, our professional organization, the American Astronomical Society, has an eclipse website. It's eclipse.aas.org. And that has a page with all the recommended viewers, recommended filters, all the ones that have been certified to be safe and are okay to order. Because during the last eclipse, we were suddenly flooded with cheap Chinese eclipse glasses on Amazon that were not properly tested. And we got really worried about this, and we couldn't get Amazon to take down some of these sites fast enough. This time we're working with Amazon, but still, if you want to know what's a good vendor to get your own glasses or to get a filter for your binoculars, eclipse.aas.org is the reliable, authoritative place to get safe viewing information. Now, one question, I'm almost done and I'm going to take questions, but one question that people often ask is, wait a minute, why does it take so many years before we see an eclipse again? After all, the moon goes around the Earth once a month. Once a month, that's where a month comes from. It comes from moon. Why, when the moon is in the direction of the sun in its monthly orbit, why don't we get an eclipse every month? And the answer turns out to be that the moon's orbit is tilted relative to the Earth's orbit. When the moon formed, it formed tilted. And so most of the time, when the moon is in the same direction as the sun, the moon is either above the sun and we don't get an eclipse, or the moon is below the sun and we don't get an eclipse. A nice way to show that to your family is to use two hula hoops, which are tilted by about 5-6 degrees. One hula hoop shows what the sun looks like in the sky over the course of a year. One shows what the moon looks like in the course of a month. And you can see that most of the time, the hula hoop of the sun is above or below the hula hoop of the moon, and the two miss each other. Only roughly every 6 months, when the two hula hoops, the two orbits cross, is it eclipse season. And so every 6 months, somewhere in the world, eclipses are possible. But most of the world's surface is water, so most of the eclipse shadows fall over water, and they're no good to us. And it can be many decades before an eclipse comes to the same country, the same community over land again. Here is the kind of eclipse calendar we keep. Every 6 months or so, eclipses of the sun and eclipses of the moon are possible. And that calendar time shifts a little bit because it's not exactly 6 months as the years go by. Here was eclipse season in 2021. Here's the eclipse season in 2024. And we can keep up with the eclipse seasons at timeanddate.com. All right. Let me just mention that there are many fun traditions associated with eclipses. For example, in many Asian countries, the legend is that a dragon is swallowing the sun. And what you need to do is bang pots and pans together and make a lot of noise to frighten the dragon from swallowing the sun. And that's what people do. And you know what? It always works. The dragon lets go of the sun and the sun is rescued. So you might see in April in some communities people coming out making a lot of noise as part of their eclipse tradition, which I think is a lovely tradition. Let's call attention to what's happening in the sky. But that's where that noise making tradition comes from. We learned about the sun's complicated atmosphere for the first time during eclipses. That's how astronomers learned that the sun also has outer layers like our own Earth has atmospheres. And nowadays we can make artificial eclipses, but still we owe a lot to past eclipses in terms of understanding our star, the sun. I want to finish by saying that the next total eclipse visible crossing the United States will be on August 12th, 2045. You might want to put that on your advanced social calendar. Some of us will need to take a lot of vitamins to still be around then. But because the next US eclipse is so far away, this is a good time. This is a time that I think most of us in the United States should take a moment to appreciate the beauty and the cyclical nature of happenings in the sky, and to understand that astronomers are able to predict these eclipses thousands of years in advance. It's a remarkable thing that we understand the sky and its cycles so well. Well, I hope I've given you something to chew on in this short introduction to eclipses. And what I really want to do is wish all of you clear skies for the April eclipse. And now I'm happy to take questions. I'll stop sharing my screen, and I'm delighted to take questions.
Thank you so much. Thank you so much, Andrew. We have a few questions in the chat. You might have touched on some of these questions in your presentation, but you might want to repeat or elaborate. The first two questions are related, so I'll read them together. Are eclipses visible with naked eyes, or do you need telescope or binoculars? Can you look at the annular eclipse without special glasses?
Okay, so I think we talked about a number. Certainly, eclipses are democratic. You don't need special equipment to see them. And it's not like some of the things where you're looking at the details of Saturn's rings. You can't see those without a telescope. The sun is very easily available. The problem is it's dangerous. So, as I said several times, the important thing to convey to kids and relatives and everyone you talk to is that it's dangerous to look at the sun when any part of the sun is showing. You can either get these eclipse glasses, you can buy them, you can get them from the library, or you can use a colander or some other way to project an image. But as long as the sun's surface is showing, it's not safe to look at. The only time the sun is safe to look at is during the few minutes when it's totally eclipsed. And then, yes, use binoculars, use telescopes, use whatever you've got to enlarge your view. Okay, Lori, back to you.
Oh, Frank wanted to clarify. His question was about his question about the naked eye was specifically about seeing the gases and other things that you mentioned in the beginning. If you're in the path of totality.
If you're in the path of totality with your naked eye, you can see the shimmering atmosphere of the sun. Sometimes you can see one of those red arches of hot material coming out with the naked eye. Just depends on how active the sun is. but it's even better with binoculars. So if you're planning to go to the total eclipse zone and planning to look at the sun during those 4 minutes, then I would recommend bringing binoculars along. And in many places, there'll be amateur astronomers projecting images of the sun and showing people the sun through a telescope during those 4 minutes.
Please explain what eclipse maximum means and why it matters.
Also, maximum means the most. So your maximum height is the tallest you ever got, and maximum eclipse is when the largest fraction of the sun is covered. And many people think that the more of the sun is covered, the sexier the eclipse. So for most people, that's what they want to see. They want to see the biggest bite possible taken out of the sun. And so that's why we always talk about what the maximum. The maximum in the San Francisco Bay Area will be 45% of the diameter of the sun covered.
Sorry, I
But
think I read the question wrong. Frank,
okay,
actually, um, clarify. Alt at max from the charts that you showed. It was one of the column headings. Alt at max.
alt at max is the altitude. How
Altitude. Oh,
the
yes.
altitude. So 0 degrees is on the horizon, 90 degrees is above your head. So that those angles, those degrees, were the altitude of the sun, where 0 is on the horizon and 90 is over your head. Thank you for asking. Good.
Okay, question. Are safety viewing glasses used in prior eclipses okay to use again this year, or do such glasses degrade over time that need to get new glasses?
Great question. So, no, the plastic doesn't degrade if you've kept it safe. But if the plastic has come into contact with any liquids, if you left it outdoors for a while, if it's crinkled or has any cuts in it, then don't use it. But if you have a pristine, safely guarded eclipse glasses in 2017, I have a bunch of them, and they're perfectly safe to use. By itself, the plastic doesn't degrade.
Thank you. Are there any stars close enough to the sun at totality that amateur astronomer can test once again general relativity?
Well, this goes back to the slides I skipped. So Einstein was a great fan of general relativity, of eclipses rather, because his theory of general relativity, his incredible theory of space and time and the warping of things, that whole theory was pretty far out and not always accepted by other scientists. And Einstein said, if you want to see if my theory is right, all you need to do is to watch a beam of starlight go by the sun, and the gravity of the sun will bend that beam of starlight if I'm right. Well, there's a small technical problem seeing beams of starlight going by the sun, which is that the sun is so darn bright. You normally can't see a star's light going so close to the sun that Einstein's effect could be tested. But during an eclipse, when the moon covers the sun and the stars come out, it's possible to see whether a star that's whose light is coming to us very close to the sun might have its star light bent. And therefore, we would see the star in the wrong place compared to its usual place. In 1919, there was a total eclipse of the sun visible from the coast of Africa. An international team of astronomers went there, took photographs of the stars closest to the sun, measured their position, and they were out of place by exactly the amount Einstein had predicted. And that's what made Einstein world famous. It was the results of that eclipse expedition that made Einstein a household word, and he still is today. So yes, this experiment has been repeated in every eclipse. There are citizen science projects underway to repeat that experiment with starlight near the sun. You need telescopes because there aren't that many bright stars right near the sun. But yes, we are going to repeat that experiment every chance we get. But it's been repeated so often now, there's no doubt about it that Einstein was right.
Okay. I bought some eclipse glasses before the last eclipse. I'm not sure if they came from Amazon. Should I discard them?
So here's my eclipse glasses. And what you need to do is to go to the back of the glasses and look for the word ISO or the symbol ISO. That's the organization that certifies optical surfaces, that deals with glasses and contact lenses and so on. Make sure that there's ISO certification. Mine says ISO conforms to and meets the transmission requirements of ISI ruling 12312-2. But something like that should be in the back of your glasses. All the glasses the libraries have that in the back, and that's a good way to check to see if you have real glasses or not.
Okay. What about welding glasses? What
Hmm.
number if some are okay?
Oh,
Welding
yeah, this
glass.
is so if you happen to have access to welding tools, which not many of us do, welding glass can be okay if it's number 14 or higher, which is a pretty high number, much more than you need for typical welding flames. But if you have welding glasses number 14 or higher, they're okay.
Last question is, where will you be viewing the eclipse?
Oh, I'm sorry, that's classified information. I'm not allowed to discuss that. No, our plans are for Texas viewing, which is, again, not my political cup of tea, but it's where the eclipse is most likely to be visible. But in any case, before we go, let me just say that I very much hope that everybody gets a chance to see it, that your families get to see it, and especially that the weather cooperates. So thank you so much for having me as part of the library's program.
Thank you very much, Andrew. We really appreciate you taking the time to share with us about solar eclipses. And I also want to thank everyone for joining the program. I hope you all find the presentation interesting to you and helpful to you. I will send out an evaluation survey together with the recording link. Please give us your feedback so we can continue to improve. Again, thank you, everyone. Have a wonderful rest of your afternoon. Bye-bye.